So, is that one a function? No, why not? Yeah, and because it's a graph, I can also still use the vertical line test, right? So if I put my vertical line right here on these two dots, it hits twice. So either repeating on the ordered pair list or the vertical line test failure there, good reasons for that to not be a function. All right, so let's look at example 8. This one's a little different because it's a graph of a line, similar to one that we drew earlier. And we know that that is or is not a function. It is a function. We know that that passes the vertical line test. So yes, it is a function. Now the domain and the range is a little bit more difficult here because we don't have individual ordered pairs. That line represents every single ordered pair that could possibly exist all the way on that. So not just the perfect places where it crosses, like right here at -4, -1. That's a great point, but it's not the only one. There's another one here at -2, 0. But there were a infinite number of ordered pairs between those two. So that line represents all these ordered pairs. So there's no way that we could list out all the ordered pairs that line represents for our domain and range. So we've got to use that interval notation that we learned when we were dealing with the inequalities. Okay, so remember, domain is what values? X values, and X values go what directions? Left and right. So when we're reading that graph, we're going to read it from left to right. What does this arrow mean about that? It keeps going to the left further and further, and a little bit downward too, right? So what's way out here further and further to the left? Keep going. It's more negatives, right? Further and further negative, we get closer and closer to what? Negative infinity. So the domain starts at negative infinity, and the arrow on the right-hand side means that keeps going that way, right? So it's going to keep going toward positive infinity. So the domain is from negative infinity to positive infinity. What about the range? Range is what values? The y value. So that, what direction do they go? Up and down. Okay. So when we're reading the range from a graph, we want to read bottom to top. So start at the bottom. So what is the lowest y value that this graph represents? Look at that arrow. It's pointing not only to the left, but down, right? So if it keeps going downward, where's it going to get toward? It's going to get to negative infinity eventually. Taking a long time because it's not going very steep. And then as we read that graph further and further up, where's that arrow pointing on the other side? Up. So that's going to get us to positive infinity. So we get both of those as being negative infinity to positive infinity, or all real numbers is the other statement that you can make there. I want you to try to get toward the interval notation because that's going to help you out in this class and college algebra if you choose to take that. All right. Now, let's look at number 9. A little tougher looking graph because it's got some weird things happening with it. Is that a function? Well, I can draw a vertical line. How many times does that red line hit that graph? It hits it 2 times, right there and right there. So that tells me that this is not a function. But it still has domain. It still has range. So domain, remember, goes left to right. What's the leftmost point on this graph? Where's it at? Maybe describe to me where it's at. Negative. So the x value would be 1, 2, 3, 4. So -4. And that y value would be -1. So which part of that's going to be the domain? -4. The x value, the ordered pair there. So -4 is where it starts. And then what direction are both of those arrows going? Remember, we're talking about domain, so it's either left or right. They're both going kind of to the right. This one's going up and to the right, and this one's going down and to the right, but they're both going to the right. So what are they going to get toward? Positive infinity. That would be the interval notation for that. Another way to write that would be x has got to be greater than or equal to -4. That's the set notation for that. Again, I prefer the interval notation. That's what I want you to focus on getting to, but maybe it helps you to understand the interval notation by seeing the inequality that goes with it. Okay. All right. Range. How do we read the range for a graph? Bottom to top. So what's the lowest part of this graph? Down here, wouldn't it? That's got an arrow on it. So where's it go to? Negative infinity. Because we're reading the y values there. X values are going to positive infinity there, but the y values are going down. So that's going to go toward negative infinity. And then as we read that up, are there any spots that are skipped in there? Any open spots or blank parts as far as I read that graph? I can follow it up this line and keep going, right? And it keeps going up. So that's going to go toward what? Positive infinity. And again, another way to write that would be all real numbers, if you wanted to write it that way. But again, I'm trying to get us going into that interval notation style, which is what I prefer. Okay. All right, and we already discussed that it's not a function because it fails the vertical line test. All right, skip over here to number 10 and get that equation or that graph there. It came from an equation. It's a graph of a circle. Okay, fails vertical line test, so it's not a function. That's good. Good to know that. All right, so what's the leftmost x value? Be right there, wouldn't it? What's that x value? Try again. -2 is the x value. I'm gonna put a bracket on that because it's a point on the graph. And then how far to the right does it go? What's that point? What's the x value for that point? 5. So the interval notation is this. Here's the set notation with the inequalities. I think the interval is easier to read. I like it better. It's a little bit more business oriented. It doesn't have all the extra stuff in there. Okay. Now range. So, bottom to top. So it looks like the bottom is right there. So what's the y value at that spot? Doesn't really matter what the x value is. It's all about what the y value is when we're talking about range. Y value, not x value. What's the y value at that spot? -2. And then the top, what's the y value at that spot? +4. And then -2. So there's the inequality version written in blue there. -2 is less than or equal to y is less than or equal to 4. But again, I like the interval version a lot better just because it looks nice. Okay. All right. This is where, if you got your graphing calculators, this will be handy on this. I'm going to show you how you can use those to kind of help you. And if you don't, you can use some of your prior knowledge to help you with this. So number 11 has y equals negative x squared plus 3. What do we know the graph of x squared looks like? Just remember from Algebra 1. What shape did it have? X squared makes the parabola shape. Hey, y'all remember doing those? Now, what happens when you put a negative in front of it? It flips it over to where it looks like this. That's it. That's what that picture looks like in general, just using prior knowledge. I'm going to show you how to graph this with your graphing calculator so you get the exact picture, but it's going to look something like that. Does that pass the vertical line test? Yes, so this is a function. So I'm going to go to the graphing calculator, and I don't know what's wrong with my screen there. Try to close it and open it back up. I need to see those numbers to be able to type that thing in. So we're going to type in the y equals menu. So we're going to hit y equals, top left button, and then we're going to type in negative. So use the negative sign down here by enter. Don't use a minus sign. It's the negative. And then x squared. So x is right there beside the green alpha button. Squared. Right there diagonally up from to the left of 7. And then I'm going to put plus 3. And I'm going to hit graph. That's exactly the same idea of the picture that we just drew from knowing about x squared graphs. Okay. Now, looking at that, we can get we get the idea of the vertical line test. So we know that's going to pass that, and it's going to be yes, it's a function. Now let's try to get the domain. Okay. So the graph looks like this. Now it's going to have arrows on it because it keeps going forever. They didn't say stop at a certain x value or start at a certain x value. So what would our domain be if it has arrows on both ends and are going opposite directions? X values left to right. If it's going further out to the right and further out to the left, what's it going to go toward? It's going to go toward the infinities. The range, and we'll read from bottom to top. It's pointing down. So what's at the bottom? Negative infinity. What's the highest place that graph gets to? Right there in the middle, right? What's that y value right there? 3. That's the highest point on the graph. So that is going to be the top of our range. Now, could you figure that out without the graphing calculator? Absolutely, you could. Remember from Algebra 1 how to find the vertex of a parabola, negative b divided by 2a, and then get that answer and plug it back in. So if you've got the prior knowledge, you can do that. Graphing calculator can kind of help you out if you don't remember that stuff. So it's a handy tool to have to get that graph. All right, let's look at number 12. What's that equation? What form is that in? Y'all remember? Slope-intercept form. And that means it makes what kind of shape? Straight line, okay? This one's going to have a y-intercept of -1 and a slope of -5. So I know it's going to look something like this graph. It'll look something like that. Not perfect like that, but it'll look something like that. Does that pass the vertical line test? Yeah. Now, what about the domain of that? Well, it's got arrows on each end, and it's going to the left and going to the right. So it's going positive. It's going from negative infinity to positive infinity. What about the range? Bottom to top. Yeah, this arrow here is pointing down, so that's going to go to negative infinity. And the y values are going up over here on the right. On the left. So that's going to be going toward positive infinity. with the graphic calculator, just get you some practice. I can hit y equals, and if I want to get rid of that equation that I've graphed already, I just hit clear, and it'll delete the whole thing. And then I'm just going to type in negative 5x minus 1 and hit graph. And there's that picture. My picture wasn't quite steep enough when I sketched it out there, but it's pretty close to that picture. Yes, sir. Do what now? Right there beside the green alpha button, there's a button that says XT, and it's got a little theta symbol and an N. Hit that. So when you type that in, you type a -5, and then hit that button. It's highlighted up in red right here. That button there, and then the -1. And then hit graph, and you should get that picture. You got something going on with you. Here's your still. Probably the same thing. You use the minus sign, not negative. Yeah, you got there. Here's the press the up here. Yeah, change color. Thank you. Part of this class is a learning curve on this graphic calculator. Anytime you use it in window range here, do that and reset your window with a 10. Anybody else have a calculator? All right. Let's look at number 13. Almost done. This is the last two. And be homework time. All right. Y equals -7. Does anybody remember what that looks like on the graph?
It goes up and down, -7.
It goes side to side. Y equals a number is a horizontal line at that number on the y-axis. So you go to -7 on the y-axis and you draw a straight line straight across. Does that pass the vertical line test? Yes. What about the domain? Yeah, it goes all the way to the left and all the way to the right, so that's -infinity to +infinity. Now here's the tricky one. What about the range? What'd you say, Don? Just -7, nothing else. It says that y is equal to -7 all the time. So to represent that, we're just going to put a -7 inside of square brackets. It says -7 is the only y value for this problem. It's the only one that exists. So that is our range for this. Okay. So if y equals a number is a horizontal line, x equals a number is going to be a vertical line. So it's going to look like this. Does that pass the vertical line test? No, because if I lay a vertical line right on top of that, how many times is it touching? All the time, every time. Yeah. So that's a no on the function. What's the domain of that? -1. Same way we did the range on number 13, we're going to do the domain on 14. There you go. Good job. Not just strenuous stuff today. A lot of stuff you've seen before.